How's it going, Mathaholics? So, today we have a new problem that we're working with, but I almost forgot to say something, so I'm going to say it now before I forget again. Once we get to 150 subscribers, we're going to give away 3 free Canes gift cards. So, if you want to have a chance to win one of those, just hit that subscribe button and even hit the like button below if you're a kind person, and we'd appreciate that. And it says that good karma and bad karma go around. So if you hit the like button, then you might get good karma and win a gift card. Who knows? So without any further ado, let's talk about fundamental counting principle. So fundamental counting principle. All right, now what is this? The definition is right here. It's basically just the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes from each stage or event. Now, I've never been one to understand math problems because of the definition. I don't read the definition and say, oh, perfect, it all makes sense to me now. So I like to look at examples, and that's what I'm going to show you all today. So now we have a real world example, supposedly. New bicycles are available with a wide selection of options for the rider. One option is chosen from each category shown. How many different bicycles could a consumer create in the chosen model? Okay, so I guess we do need to understand a little bit of the definition, and to do that, we'll go back to it. So it says that sample space can be found by multiplying the number of possible outcomes from each stage or event. Now, that is all we have to do. We just need to multiply the 9, the 3, the 3, the 4, the 2, the 3, and the 2. And once we do that, you will get a whopping total of 3,888. Right there. And what does that number mean? That simply means how many different bicycles could a consumer create in a chosen model. So if we're the manufacturer and we're trying to see how we want the bicycle to look, if this is going to be really bad, but I'm going to do it anyway. If we want the bicycle to look like this, let's give it a seat. There we go. If we want the bicycle to look like that, we can. Or if we want the bicycle to look, let's see. If we want the bicycle to be green, that's a possibility. Why is that a possibility? Because there's 9 possibilities for colors. It says so right over here. That is not what I was doing. It says so right here. If we want a different gear shifter, okay, there we go. That's a gear shifter. We have 3 different options. Okay, now we have gear shifters on both sides. If we want the seat material, right now the seat is a square. If we want the seat to be shaped, I was gonna make it a triangle, but I don't think that would be too appealing to anybody. If we want the seat to be shaped like a circle, we can do that. If we want the brakes, if we want brakes on the wheels, we can have brakes on the wheels. If we want the brakes to be on the handlebars, we can have brakes on the handlebars because we have 4 different options. So that's basically what that number means. A very simple way of getting it. You just multiply all of these possible outcomes together, and then the total, that's your answer.